$1.1 trillion represents a structural turning point in the global economy. This milestone marks the moment a single individual consolidated the financial and physical infrastructure required to dictate the development of frontier AI. Tracking this wealth requires looking at balance sheets rather than bank accounts. Net worth is a moving snapshot, an estimate built from public stock prices, private valuations, and stock options, with debt subtracted from the total. The valuation solidified on June 12, 2026, when SpaceX launched its IPO under the ticker SPCX. The offering raised a record $75 billion and valued the company at an historic $1.77 trillion. This valuation defies the standard logic of the aerospace industry. Traditional rocket companies operate with high overhead and thin margins, rarely earning the massive valuation multiples usually reserved for software monopolies. SpaceX's own IPO filings explain the anomaly. The documents reveal a strategic transition toward artificial intelligence, shifting the company's core value from orbital launch capabilities to AI infrastructure. To understand how the market arrived at this number, we have to look at the financial engine that first established the founder's credibility with investors. In 2018, Tesla shareholders approved an all-or-nothing pay package for their CEO. The deal was tied to extreme market cap targets that many analysts initially dismissed as impossible to achieve. Tesla met those targets through rapid industrial execution. The Shanghai Gigafactory moved from breaking ground to delivering finished cars in roughly a year, a speed previously unheard of in global automotive manufacturing. By 2021, Tesla crossed $1 trillion market cap. The market began valuing the company as a scalable software and energy platform with a manufacturing arm attached. This pattern of hitting extreme milestones created the Elon Premium. It is a specific form of market credibility where a founder's future promises are priced as inevitable certainties by investors. Tesla's ability to hit these extreme targets established a pattern of execution that investors began to price into every subsequent project. SpaceX filings show it spending like a tech giant. The AI division reported $818 million in revenue, posting losses around $2.5 billion. This spending is highly concentrated. AI infrastructure took 76% of the $10 billion capital budget, dwarfing traditional aerospace expenses. Usually, the market punishes this level of cash burn. In this case, investors rewarded it. The reward is based on vertical integration. Investors back a unified stack controlling compute, data, and distribution. xAI built the foundation, the Colossus supercomputer, linking 100,000 GPUs in 122 days for massive raw compute. The chain continues with X supplying real-time data to train the models, xAI providing the compute, and SpaceX acquiring both to internalize the entire system under one corporate umbrella. The $1.77 trillion valuation reflects the market's appraisal of a closed-loop AI monopoly rather than a traditional aerospace firm. The race for frontier AI has shifted. It is now a battle of raw capital and the industrial-scale infrastructure required to support it. Controlling a trillion-dollar asset pool allows a founder to bypass venture capital gatekeepers. They can hire talent, fund compute, and set industry standards unilaterally. This wealth creates a significant competitive advantage. This single corporate structure can absorb billion-dollar losses that would end the operations of most competing firms. The IMF has noted that AI can widen economic inequality when the returns flow primarily to a very short list of capital and compute owners. These financial dynamics transformed AI from an open technological field into a highly concentrated infrastructure play. Public benefits of this scale include the rapid rollout of technology like Starlink, which expands broadband reach to rural areas that terrestrial internet cannot serve. However, there is a risk of significant job churn. Entry-level white-collar roles in coding, writing, and analysis face disruption as these models are integrated into the economy by 2030. The physical demands of this era are equally intense. Data centers consumed 4.4% of U.S. power in 2023, and that requirement could reach 12% by 2028. The trillion-dollar milestone is the result of an engineered system where wealth, hardware infrastructure, and market narrative reinforce one another across multiple industries. A wealth pool of this magnitude creates permanent leverage over the direction of the global future. Navigating the next decade requires understanding the capital structures and power grids governing our technology.